Math 100 Lesson 10.2 deals with rational exponents. And before we get into that, let's just review the rules that we covered in 10.1. So our rules that were covered in 10.1 are, if b squared equals a, then b equals the square root of a. The square root of a squared is the absolute value of a. If b cubed is a, then b is the cube root of a. The nth root of a to the nth is the absolute value of a when n is even. And the nth root of a to the nth is just a when n is odd. So these rules have not gone away. We still are going to use those today. But this time we are going to have rational exponents. And when you see that little word rational, it means fraction. Yay, fraction exponents. So our newest rule for today is going to look like this. Okay, so we've got a raised to the 1n. Okay, so here's how the rule goes for that. This really means the nth root of a to the first power. Right? So my denominator is the root. The 1 up here is that exponent. Okay, that's where that comes from. So a to the 1 over n is the nth root of a to the first power. Excuse me. So if I had 64 to the 1/2, that would mean the square root of 64 to the first power. Notice I didn't write the 2 or the 1, because when you write square root, you don't usually write the 2. And when something's raised to the first power, you don't usually write the 1. All right, the square root of 64 is 8. Let's try another. If I have negative 8 raised to the 1/3. Okay, this time I am going to write that 3, okay, because we do write it when it's not a 2. So we're taking the cube root of negative 8, and again, I'm not going to write the 1 because when the exponent is 1, we don't write that. All right? So the cube root of negative 8, if I think about it like this, that is negative 2 cubed. So now I can use my little rule over here that says, this last rule from 10.1, the nth root of a to the n is a. So I get negative 2. No absolute value is needed because my n value is odd. Okay, now I have all of this, 6x squared y in parentheses, raised to the 1/5. So that 5 is my radical. Okay, that's the root I'm taking. And then I'm going to put 6x squared y. Now, it's raised to the first power, so I don't have to put that 1. Now, that cannot be simplified, so that is done just like it is. Alright, so I'm just going to give you a couple of problems, and what we're going to do is we're going to rewrite each of them using rational exponents. So we're going to go backwards, okay? We're going to go the other direction. Alright, so I've given you the radical, and we're going to rewrite it with a rational exponent. So all the stuff that's inside, we're going to put in parentheses, and we know there's not a 1 there because we don't show the 1, but there is a 1. So this would be raised to the 1/5. So that would be our answer here. 13ab to the 1/5. You must have the parentheses. Let's try another one. Okay, now let's don't make this difficult. Take the stuff that's inside. All right, here here's all the stuff that's inside, put it in parentheses, and we raise it to the 1/7. Okay, the 7th root. Now, that top number is not always a 1. Okay, so let me give you another little rule for when that little top number is not a 1. N is still going to be our root, and M is still going to be our exponent. It's just not always going to be 1. But another way to write that is sometimes super helpful is for us to say the square root of A and raise the whole thing to the M. Now, either of those is correct, but sometimes it's easier to simplify the second one. All right, so if I have 1,000 to the 2/3. All right, so the 3 is my radical. The 2 is my exponent. Now, I can tell you this. If you square 1,000, there's a good chance you're going to mess up on writing down zeros, okay? So I'm going to do this one differently because we don't have a cube root button on our calculator that we're supposed to be using. So I'm going to rewrite this one the second way and put the squared on the outside. Now, the reason I want to do that, I can do the cube root of 1,000, right? The cube root of 1,000. 1,000 is 10 cubed. So the cube root of 10 cubed is 10, and now it's still squared, which gives me 100. Now it's super, I know that some of you are like, oh, I'll just put it in my calculator. A lot of these are going to have variables, and you're not going to be able to put the variables in your calculator. So make sure you're able to do this without having to hit those buttons on your calculator. Now remember, you're supposed to be using a 4-function calculator that should not have a cube root or a square. It will have a square root. It should not have a cube root. And it certainly shouldn't have an exponent button. Okay, if I take this one, we're doing the square root of 16 cubed. Again, I can't do 16 cubed. Now on your little calculator you could say 16 times 16 times 16, but then I can't take the square root of that. So I'm not going to do it that way. I'm going to write the square root of 16, and I'm going to put the cubed on the outside. Because I can do the square root of 16, it is 4. Now I can cube 4. 4 times 4 times 4 is 64. So that would be my answer. Okay, now big mistake here that people make is they go, oh, that's negative 32 raised to the 3/5, and it is not. Let me write it differently. These are two different problems. This one says negative 1 times 32 to the 3/5. So this would be negative 5th root of 32 cubed. This one would be the 5th root of negative 32 cubed. Big difference in the way that that is initially written. All right, so let's do both of them. Right here, this negative's on the outside. The 5th root of 2 to the 5th. All right, so the 5th root of 2 to the 5th is 2 cubed. Now the 2 is the only thing cubed, I get negative 8. All right, so this is where some of you are going to be like, why did you even bother? Stick with me. Knowing the rules is what's important here. All right, so the 5th root of negative 2 to the 5th is still negative 2, and that is cubed, which is negative 8. Now, I know that we got the same answer on both of these. However, if that had been an even root, if the 3 had been a 4, Okay, now we've got a big difference. If the 3 had been a 2, then one of these answers would be positive and one of them would be negative. So you do have to be careful. Those were 2 different problems. All right, so we're going to go backwards again, and we're going to rewrite using rational exponents. So this time I give you the radical, and you change the way that it looks. Okay, so I've given you the radical. Now we're going to write it with rational exponents. So this would be 6 to the 4/3. All right, let's do another one. If I had the 5th root of 2xy, all of that raised to the 7th. So I'm going to take the 2xy, it's going to be put in parentheses. The 5th root, that's my denominator, and the 7 goes up there in the numerator. Okay? All right, so our next little rule says, what if our exponent is negative? What if our exponent is negative? Well, we've already covered negative exponents, and that means put it in the denominator. Okay. Now, we have learned that a rational exponent means this is the square root of a to the, I can raise the whole thing to the m. Remember, I can write it either way. Okay. So let's simplify using that rule. If I had 100 to the negative 1/2, that means the negative 1/2 means put the whole thing in the denominator, and now it's a positive exponent. Okay, not finished, because 100 to the 1/2 means the square root of 100, which is 10. So we get 1/10 for our answer. These rational exponents tend to get a little tricky for people. A negative exponent, all it does is puts it in the denominator, and now the negative exponent is a positive. All right, now this says the cube root of 8 to the 1st power. The cube root of 8 is 2. So our answer here is 1/2. Okay, still simplifying. All right, now that negative exponent just means put it in the denominator. Then the exponent becomes positive. All right. Now we're going to use our radical signs to help us out. So we've got the 9th root of 3xy, and I can put this 5 on the outside. Okay, that would be my answer. Let's do one with just numbers again. All right, 32 to the negative 3/5. That negative exponent means put it in the denominator, and it will become a positive exponent. Now we take the 5th root of 32, and we take that answer and cube it. Well, the 5th root of 32 is 2, and then we cube that, so 2 cubed is 8. So we end up with 1/8. All right, these just take some practice. There are a couple more rules for us. Okay, so let me just remind you of some old rules. All right, these are just things we've already done this semester that are going to be helpful. If I am multiplying two expressions that have exponents. To multiply those, I add the exponents. If I am dividing two expressions, then I would subtract top exponent minus the bottom. If I have a power raised to a power, I multiply the exponents. These are old rules. If I have a product raised to an exponent, then I raise everything in the parentheses to that exponent. Okay, even if that was a division, the numerator gets raised to the exponent and the denominator gets raised. Now those are old rules, that's nothing new, but I just want to remind you before we do our fraction exponents, because these rules right here are going to apply. So we're still simplifying. 6 to the 1/7 times 6 to the 4/7. Okay, that's this first rule up here. Okay, old rule, just an old rule. When we're multiplying, our bases are the same, we add the exponents. So we add 1/7 plus 4/7. Now we actually do that, and we get 5/7. Now in My Math Lab, you need to pay attention to the directions. If it wants you to write your answer as a rational exponent, then this would be correct. If it wants you to use as a radical expression, then that's where we would write it using a radical. So pay attention to the directions. People tend to miss these just because they don't read the directions well. Okay, so 50x to the 1/3 divided by 10x to the 4/3. Okay, well, we would do 50 divided by 10 and we get 5. Now when we're dividing, we use the second rule of reminder up there. We subtract the exponents, top exponent minus bottom exponent. So this gives me 5x to the -3/3. Well, I can simplify 3/3. That's -1. Okay? Now that -1 means put it in the denominator, but -1 is only on the x. So the x goes to the denominator, but the 5 does not. Oops. Okay, that is a 5 right there. Okay, so I've got 9.1 raised to the 2/5, and then the whole thing is raised to the 3/4. So we have a power raised to a power. So really this is 9.1 to the 2/5 times 3/4. Power raised to a power, we multiply the exponents. Okay, now when I'm multiplying these, I can simplify. 2 goes into itself once, it goes into 4 twice. So I have 9.1, and now my new exponent is 3/10. So this would be my answer. 9.1 to the 3/10. That is a 5. Okay, so I have x to the -3/5, y to the 1/4 multiplied together, and then all of that raised to the 1/3. So a couple of ways I can do this. But what I'm going to do is I'm going to say, okay, I have a power raised to a power. So everything in there gets raised to that power. So negative 3/5 gets multiplied by 1/3. Power raised to a power, you multiply. Y to the 1/4 gets multiplied by 1/3. Power raised to a power gets multiplied. Now I have to do both of those. So I get x to the, now when I multiply here, I can simplify. So I end up with negative 1/5 y to the 1/12. Now that negative 1/5, you can never leave a negative exponent in your answer. So that means that that x to the 1/5 has to go to the denominator, but the y to the 1/12 stays in the numerator. So this is what my answer would look like. Okay. All right, I've got a couple more, and we'll be done. All right, so my directions are still simplify, and I'm going to add to my directions this time and say use rational exponents. This is where reading the directions is going to be super important in my math lab. All right, so I've got the 6th root of x cubed. Okay, so if I rewrite that using rational exponents, it would be x to the 3/6. Now, that can be simplified. You can simplify that fraction to say 1/2. Okay, now this would be rational exponents. All right, that would be that answer. If the directions ask for the answer in radical form, it would be the square root of x. You would take x to the 1/2 and you write it as a radical. Okay? So pay attention to, do the directions ask for rational exponents or is it asking for radical form? They are different. I am asking for rational exponents here. Okay. So I've got this radical. I'm going to write it as rational exponents. All right, everything inside gets raised to the 1/3. Okay, not finished because I need to simplify. Now everything in parentheses gets raised to the 1/3. Power raised to a power, I multiply. So the 8 to the 1/3 is 2. The cube root of 8 is 2. And if I think about this, I can simplify that fraction and I get a to the 4th. So my solution here would be 2a to the 4th. All right, so we learned some new rules and refreshed you on some old ones. And that is all for section 2. Please make sure you practice this before you try to move on to the assignment for section 3.